Hello everyone, welcome back to our tutorial on volume and surface area of pyramids, cones and spheres. Okay, so in this example we have a pyramid which it has a square base of 10 cm and the surface area of triangle face VBC is 43 square centimeters. Find the volume of pyramid. So you notice the marks allocation is 4 marks, right? So it will require quite a number of steps, but don't worry, I'll guide you through to find the answer for this question. Okay, volume of pyramid. So let's write down how to get the volume of pyramid. So volume of pyramid is equals to 1/3 times by base area times by h. So in this case, the base area is quite simple. We know the base area is a square base, right? So it's 10 times by 10. We have the base area. 1/3 is just a constant. So now the height is the problem. Let's look at the height. Let's go back to this question here. Let's trace my pen. Look at my pen in blue here. The height is basically this blue color line. This is h. We do not have this value, but what they give us is the surface area of VBC. VBC is equals to 43 square centimeters. Let's follow my red color line. So VBC is equals to 43. So the area of this triangle is obtained by taking half times by base, which is 10, okay, times by this height. Height is in green color. So this one is the perpendicular height. Okay, so that is the height of that triangle. And how does this relate to our height of the pyramid? Okay, so now follow my yellow color pen here. So the yellow color pen is this one here. Okay, do you see the yellow color triangle or orange color triangle in the pyramid? That is how we are going to use to find our height of pyramid. Okay, so our first objective is to find the height of triangle VBC, and then we're going to apply Pythagoras theorem to get our height of pyramid. Okay, so let's work it out. So we're going to find the height of VBC, triangle VBC. Okay, height of triangle VBC is equals, this is how we're going to get the half times 10 times by half times base, which is 10 times by height, is equals to 43. So in this case, h is simply the height of triangle VBC is simply 8.6 centimeters. Okay, so let me draw a separate triangle. This is the side profile of our pyramid. V is the apex of that pyramid, and then this is the center. Let's name the center as let's name it as x, and then this point here, okay, this point in red is the height of triangle VBC. Let's call it point y. Okay, and this is obtained earlier on, 8.6, and the length of xy is basically half of the length of AB, which is 5 centimeters. So this is our h. Okay, this is the h that we're looking for to find the volume of pyramid. And again, this triangle, VXY triangle, is a right angle triangle because it is a right pyramid. Okay, so to find h, we are going to apply our Pythagoras theorem. Okay, so h square plus 5 square equals to 8.6 square. Okay, so h is simply 8.6 square minus 5 square with a square root. Okay, type the numbers in your calculator, you will get 6.9971. That is the height of our pyramid. Okay, so now that we know the height of a pyramid, we can get the volume. All right, so therefore volume of pyramid is equals to 1/3 times by base area. Like I mentioned, the base area is a square, so it's just 10 times by 10, then times by 6.9971. Okay, again, using our calculator, 6.9971 times by 100 times by 1/3. Okay, and we will simply get 233.237. So the three significant figures will be 233 cubic centimeters. Okay, so the learning point here for this question is that we are working backwards. Okay, always start with the end in mind, which is to find the volume of pyramid, and then from our volume of pyramid, we identify that we know 1/3 is just a constant. We have all those information. The base area is a square and dimension is given. So our objective is to find the h, which is not given in our diagram. So we go back to our main diagram. The h, the height of pyramid is obtained by utilizing the area of triangle VBC is 43. Okay, so the area of triangle, from there we can get the length Vy as per this triangle here. Okay, and from there we apply our Pythagoras theorem to get the height of the pyramid. Okay, next thing, the other thing that you need to take note of is, let me just tidy up this diagram. Okay, what you need to take note of is that for your pyramid, this distance to this distance is just half of your AB. Okay, if let's say you have a rectangular pyramid, the length from here, from the center to this part, is just half of your this length here. Okay, but in our case, because it's a square pyramid, it doesn't matter. Both values are the same. In case you have a rectangular pyramid, so from here, the distance from here to here, let's say this one is 12, therefore this one will be 6. Okay, if let's say you have this length is let's say this one is 10, therefore this distance will be 5. They are no longer the same. Okay, it's different. That is something that you all need to know. Okay, so till then, that's it for this example. I'll see you at our next video.